So let's talk about absolute convergence for infinite series. So first of all, let's just define this. So a series a sub n converges absolutely if the corresponding series of absolute values, so if I take the series absolute value of a sub n, if this converges. So if this converges, then this converges absolutely. So it's pretty well named. Okay, so we have what's known as the absolute convergence test. So if this converges the absolute value of our series, then so does our original series. So if it converges absolutely, then the series itself converges. So it's a pretty straightforward test, really. And so let's just look at a few examples of this now. So for my first one, so this is kind of why you want like an absolute convergence test, because I've got this -1 to the n and then 1 over n cubed. So this -1 to the n might feel like it's making everything harder. And so the nice thing is then if you have the absolute convergence test, like you can just ignore this for a second and focus on 1 over n cubed. And of course, we know that if I take the absolute value of this, that will just leave me with 1 over n cubed, and that converges as a p-series. So it just makes our lives a lot easier to have this absolute convergence test. In another example, so I think this would be a good one. You can think about this one on your own if you would like. You can pause and think about it for a second. So how will absolute convergence help us in this case? Okay, well, in this case, you know that cosine is typically wedged between -1 and 1. But if we're talking now about taking the absolute value of this, then we're going to have that this is just always going to be greater than or equal to 0. So this will end up being just between 0 and 1, right? And so if I think about taking the absolute value then of all of these terms, so the denominator is already positive, so we don't have to worry about that. But if I just think about, okay, I don't know what cosine of 1 is, but now I know that it's going to be something less than 0 but less than 1 but greater than 0. So now I have like a better sense of kind of what's going on with the top here. And so because of that, we can say that this particular series, so this here, this I can compare with just 1 over n squared, right? So that series will always be less than or equal to 1 over n squared. And so since this converges, then this must converge absolutely and therefore converges. So there's kind of that nice interplay there. Okay, so this is it for this video. It's super short and sweet, so just introducing this test. So in the next videos, we will discuss some more specific tests that you can also use with this. So I'm going to leave it at that, and I'll catch you guys in the next videos. Bye!